Hey guys, welcome back. So in this video we're going to discuss when you should use an interface and when you should use an abstract class. So recall that when you have an interface, all you're doing is you're defining something similar to a class, except you're using the interface keyword, and then you're just defining a bunch of method headers or abstract methods. An abstract method is one that doesn't have a definition, and in this case this doesn't have a definition, so we call it an abstract method. But this abstract method is inside an interface. Now, we can create, let's see here, what is this test class? This is also an interface. Now, consider this do something function or method. Because it's inside of an interface, we can't provide any kind of implementation for it. But if we were to make our animal class abstract, for example, we could, and we're getting a compiler error because we can't actually create any instances of an abstract class. I'll just show this to you guys. Animal, if we were to do this, we would have to use an anonymous inner type. Anyways, back to this. With an abstract method, we can do maybe, okay, so what do animals do? They can walk. A lot of animals walk. So if we want to declare a method called walk, we can declare it as abstract, which forces us to implement that method if we want to create an object of it, an object of the animal class. And so we override it and we can now create an animal object. But we can also do this. We can do public void. We can also do this. We can define a method called eat, and we can provide a definition for it. Eating. Oops. I am eating. So we can provide a definition for it. And this is advantageous because now we can just do animal.eat and the implementation is there for us. But we were not able to do something like this inside of an interface. If we try, then we're going to get a compiler error. We're going to get a compiler error because you can only declare abstract methods inside of an interface. Okay, so now that we've seen this, let's look, or actually before we jump into the new topic, let's actually look at one more case where we would use an interface over an abstract class. So an abstract class, it's related to kind of like an object. So we make animal abstract because we have some methods inside of it that are going to be abstract. For example, this walk method, it should be abstract. Why should this walk method be abstract? Well, because every animal might walk differently. For example, humans walk on 2 legs, but cats walk on 4 legs, and dogs walk on 4 legs. So if we created a dog class that's subclassed animal, we would actually need to provide this walk functionality for each of those different subclasses. We would require that the human class override this walk method, and we would require that the dog class override this method and provide their own implementations. We could apply the same logic to the eat method, but for just the sake of this example, let's just assume that every animal eats the same way. If you're in that kind of scenario where the method is related to the type of the object, then you should use an abstract class. But an interface is a lot more generic. When you use an interface, anything can implement it. Anything. So you don't, like, even a car class, for example. A car class can implement my interface. It doesn't have to extend an abstract class that might be related just to animals, but it can implement this interface that is shared between this animal and car. So animal implements this and car implements this, and anything that has this do something functionality can implement it. We could have a star class, for example, and it would implement this do something function, and that would make sense just because an interface is very generic, and anything that has this do something functionality, we want them to implement it. All right, so those are the scenarios in which you would use an abstract class over an interface and vice versa. I'll see you guys in the next lecture.